The empirical formula of a compound is the simplest ratio of the elements in that compound, and it can be worked out once you are given the percentage composition of that compound. You are either given the actual percentages of the various elements in the compound, or you are given the masses of the various elements in the compound. I'm going to do one of each on the board. The first one is going to be a fairly straightforward one, and the next one is going to be a slightly more complicated one. The first example is one where you are given the percentages of the various elements. This is a compound that contains 39.9% carbon, 6.7% hydrogen, and 53.4% oxygen. So when you are given percentages, it's best to try and convert those to masses. So because they are percentages, we can say, right, in 100 grams of this compound, 39.9 grams is carbon, 6.7 grams is hydrogen, and 53.4 grams is oxygen. So now that we've got masses, we can now calculate the number of moles using these masses and the molar mass. So the number of moles of carbon is 39.9 divided by 12, and we're going to get 3.33 moles. And then the number of moles of hydrogen, 6.7 divided by 1 is 6.7 mole. And then the number of moles of oxygen is 53.4 divided by 16, and we get 3.34 mole. Now the next step is to divide by the smallest number of moles that we have, which is clearly 3.33. So we're going to divide each one. So this is our first step over here. So our first step is to calculate the number of moles. The second step is to divide through. So we're going to divide 3.33 divided by 3.33, and you're going to get 1. Right, so that's your carbon. And then 6.7 divided by 3.33, you actually get 2.01, which is almost 2, and that is your hydrogen. And then 3.34 divided by 3.33 is also 1, and that is your oxygen. So there you see that you have the ratio of 1 carbon to 2 hydrogens to 1 oxygen, and so therefore your empirical formula is CH2O. In this example, you've already been given the masses, so let's go right into it and find the number of moles of each. So the number of moles of iron is 34.97 divided by 56 equals 0.62 mole, and the number of moles of oxygen equals 15.03 divided by 16, and we get 0.94. So that's always our first step, is finding the number of moles. Remember the second step, dividing through by the smallest number of moles, which is clearly this. So we're going to say 0.62 divided by 0.62, and we get 1. So that's my oxygen, that's my iron. And then 0.94 divided by 0.62, I get 1.5, and this is my oxygen. Now, you know that we cannot have a decimal in any kind of formula. So if you get one like this where you are left with a decimal, you've got to then multiply out both until you get a whole number. So what we're going to do is we're going to multiply them both by 2. So then you're going to get 2 irons, and you're going to get 3 oxygens. Therefore, my empirical formula for hematite, which is an oxide of iron, is Fe2O3.